Well, well, well. We have a parallelogram, two pairs of opposite sides parallel. We want to prove that F is congruent to H, this baby does this one, and JH. So we want to prove that opposite angles are congruent. Okay, let's see. We've got given, line 1. Line 2, angle J and angle F. We can refer to these as single letter answers because there's only one angle that works with them. So J and F is 180 and G and F is 180. That's because these are, and I'm going to redo this, or actually maybe I'll just write over it. I'm going to write these parallel lines and extend them a little bit. So F and J and F and G and F, those are same side interior angles. And those are complementary or supplementary. It's called the same side interior angle theorem. And I'm just going to put S-U-P-P-L-E-M-E. Because we have proven already that those same side interior angles are supplementary. We put J and F and G and F, standard move. You should know this by now. That's the transitive property. And another standard move, when we've got J and F and G and F, we can subtract those F's to leave J and G. That's just by the subtraction. So we've got actually the second part of the proof we want to do. Now I think it's the same thing. We just look at it from a different angle. H and G and F and G, that is the same thing. Same side interior angles. Same side interior angles theorem. Now H and G is congruent to F and G. Oh, they're making us fill this in by the transitive property, and we've got G's that are in common. We can make H congruent to F by subtraction. Voila, done. Whoa, we're on a roll. Let's go to 14. It looks like ABCK is a parallelogram and DEFK is a parallelogram. I'm going to draw in those lines then. If these lines are parallel, I'm going to indicate it, and it's ABCK is a parallelogram. These lines are parallel. I'm going to indicate that because some nice relationships are going to happen. Line 1, given. Line 2, FKD. FKD, ACK, those are vertical angles. And now in that parallelogram ABCK, CKA, that's this one, is congruent to, that's the opposite over here. That's oh man, what's that called? Opposite. Oh, in a parallelogram, opposite angles are congruent. Oh, that's nice. It's got it for us. I should just fill out what I need to. CKA should be CBA, but I believe you could also call this angle B, which I think is an option. And FEDK. So now we're looking at this other parallelogram. FKD is congruent to, and now I think we're going to go with the same thing. If that's a parallelogram, opposite angles are congruent, so we want to link angle E. And now we have FKD is congruent to AKC, and that's congruent to B, that's congruent to E. We have E congruent to B by transitive property.